This tutorial is prepared using information developed by Charlie Lloyd, Mapbox. Landsat 8 is an American Earth observation satellite launched on February 11, 2013. It is the 8th satellite in the Landsat program, the 7th to reach orbit successfully. The two main sensors for Landsat 8 are the Operational Land Imager, OLI, and Thermal Infrared Sensor, TIRS. The Operational Land Imager, OLI, produces 9 spectral bands, band 1 to 9, at 15, 30, and 60 meter resolution. Then, the Thermal Infrared Sensor, TIRS, consists of 2 thermal bands with a spatial resolution of 100 meters. Band 1 senses deep blues and violets. Blue light is hard to collect from space because it's scattered easily by tiny bits of dust and water in the air, and even by air molecules themselves. This is one reason why very distant things, like mountains on the horizon, appear bluish, and why the sky is blue. Just as we see a lot of hazy blue when we look up at space on a sunny day, Landsat 8 sees the sky below it when it looks down at us through the same air. That part of the spectrum is hard to collect with enough sensitivity to be useful, and Band 1 is the only instrument of its kind producing open data at this resolution, one of many things that make this satellite special. It's also called the coastal/aerosol band, after its two main uses, imaging shallow water, and tracking fine particles like dust and smoke. By itself, its output looks a lot like Band 2, normal blue, but if we contrast them and highlight areas with more deep blue, we can see differences. Bands 2, 3, and 4 are visible blue, green, and red. Band number 5 near infrared, near, this part of the spectrum is one of the most frequently used, as healthy plants reflect it the most, the water in their leaves scatters the wavelengths back into the sky. This information is useful for vegetation analysis. By matching this band with others, one can get indexes such as NDVI, which provide more precise measurement of plant condition compared with looking only at the visible greenness. Bands 6 and 7 cover different slices of the shortwave infrared, or SWIR. They are particularly useful for telling wet earth from dry earth, and for geology. Rocks and soils that look similar in other bands often have strong contrasts in SWIR. Band 8 is the Panchromatic, or just Pan, band. It works just like black and white film. Instead of collecting visible colors separately, it combines them into one channel. Because the sensor can see more light at once, it's the sharpest of all the bands, with a resolution of 15 meters. Band 9 shows the least, yet it's one of the most interesting features of Landsat 8. It covers a very thin slice of wavelengths, only 1370 plus or minus 10 nanometers. Few space-based instruments collect this part of the spectrum, because the atmosphere absorbs almost all of it. Landsat 8 turns this into an advantage. Precisely because the ground is barely visible in this band, anything that appears clearly in it must be reflecting very brightly and or be above most of the atmosphere. Band 9 shows the least, yet it's one of the most interesting features of Landsat 8. It covers a very thin slice of wavelengths, only 1370 plus or minus 10 nanometers. Few space-based instruments collect this part of the spectrum, because the atmosphere absorbs almost all of it. Landsat 8 turns this into an advantage. Precisely because the ground is barely visible in this band, anything that appears clearly in it must be reflecting very brightly and or be above most of the atmosphere. Band 9 is just for clouds. Bands 10 and 11 are in the thermal infrared, or TIR. They see heat. Instead of measuring the temperature of the air, like weather stations do, they report on the ground itself, which is often much hotter.